Good morning, gentlemen. In today's lesson, we're going to continue with our Chapter 9 notes, page 6 onwards. Okay, so we're looking at ratios involving three quantities. Now, let's look at example 5a. You have 4 over 5 is to 2/3 is to 1 and 1/4. So if I write it as 4 over 5 is to 2/3 and I convert this to an improper fraction, it'll be 5 over 4. How do I simplify this? Question says I need to simplify the following ratios. Okay, how do I simplify it? Very simple. Basically, all you need to do is to multiply or divide every term by the same constant. So if we look at these three fractions, right, what is the LCM of 5, 3, and 4? That's right, the LCM is 60. Okay, so all we have to do is to sort of make it over the common denominator. So we have 48 over 60 is to 40 over 60 is to 75 over 60. Okay, so all I have to do to simplify is to multiply every term by 60 and I will get this as my final answer. 48 is to 40 is to 75. And we're done. Let's look at part B. So part B, we have 1.8 is to 5.4 is to 0.9. Now in order to simplify, I'm going to multiply every term by 10 first. So I have 18 is to 54 is to 9. Okay, I multiply every term by 10. Then after that, I can just divide every number by 9 to simplify. Because this is not in the simplest form, right? I can still divide by 9. So my final answer is 2 is to 6 is to 1. Easy. All right. Now let's look at example 6. Question says, if x is to y is equals to 5 is to 6 and y is to z is equals to 4 is to 9, find x is to y is to z. So how do we do this question? Now, I'm going to write it separately here. X is to y is 5 is to 6. And then y is to z is 4 is to 9. Okay. Now the y is common for both, right? So I'm going to find a number that is common to both ratios for y. Okay. And in order to do that, I realized that, oh, I should just multiply the first ratio by 4. So I get 20 is to 24. Then the second ratio, right, I want to make the y the same. So in order to make 4 24, I'm going to multiply by 6. Okay, so I get 24 is to 54. Then I realized that, oh, now for both cases, my y is 24. And therefore, in order to express x is to y is to z, I can just write it as 20 is to 24 is to 54. But this is not in the simplest form, so I'm going to convert it to the simplest form by dividing by 2. So I get 10 is to 12 is to 27. And this is my final answer. Moving on, how do I find x is to z? Okay, so I use the ratios here that I wrote below. I will take 20 is to 54. Once again, not in the simplest form, so I will reduce to 10 is to 27. And that's my final answer. Okay? Okay, let's move on to example 7. Let's read the question together. It says, a sum of money is divided among Khairul, Michael, and Ethan in the ratio 6 is to 4 is to 5. After Khairul gives $30 to Michael and $15 to Ethan, the ratio becomes 7 is to 6 is to 7. Find the amount of money Khairul had initially. That means at the start, before he started giving out all his money. Okay, so let's write it out in terms of a ratio. Initially, right, K is to M is to E is in the ratio of 6 is to 4 is to 5. Then later, okay, after giving out everything, K is to M is to E became 7 is to 6 is to 7. Now, if we look at the total number of units, there was initially, right, 6 plus 4 plus 5. Initially, there were 15 units. Okay, but then later, after giving out the money, 7 plus 6 plus 7, total number of units is 20 units. So if we go and find the LCM between 15 and 20, we realize it is 60. Okay, so in order to get 60 units, we need to times 4. Okay, and then over here, in order to get 60 units, we times 3, we get 60 units. Okay, so what we're going to do is to multiply everything initially by 4. Okay, so over here, right, this will become 24 is to 16 is to 20. And then for the second ratio, for the later part, we're going to multiply every number by 3. So we get 21 is to 18 is to 21. Okay, and then now we look at the number of units that has been given away to other people. So question says that Khairul actually gave $30 to Michael and $15 to Ethan. So if you look at it, right, the $30 to Michael, Michael actually had 16 units at first, but after he got some money from Khairul, it became 18 units. So that 2 units, right, is actually the $30, right? Because Michael had an increase in $30. So 2 units represents $30, and therefore 1 unit represents $15. Okay, so question says how much money did Khairul had initially? Basically, that's 24 units. So you just do your simple math. 24 times 15. Final answer is $360. So Khairul had $360 initially. If you want, you can write a statement. Just to be clear, Khairul had $360 initially. Makes sense, right? Because he gives $30 to Michael, so that's 2 units. And then he gives $15 to Ethan, so that's 1 unit. That is why Ethan goes from 20 units to 21 units. And then because Khairul has given away 3 units in total, right? That's why Khairul goes from 24 units to 21 units. Okay, so this is how you do this question, and final answer is $360. All right, let's move on to the next page. Page 7, all about the golden ratio. Now, you may have heard about this golden ratio being present in many things around us, like in nature, in flowers, in architecture, etc., etc. Okay, so after this page, right, I'm going to share with you another video more about the golden ratio and how it can be found all around us. Okay, but for now, right, on your notes, if you look at this famous drawing, okay, let's look at points A, B, and C. And now we're going to find the lengths of AB and AC and find the ratios AC over AB and AB over BC, correct to 2SF. Okay, so if you use your ruler and do a quick measurement, you realize that AC is about 5.6 cm, AB is about 3.5 cm, and BC is about 2.2 cm. Okay, so let's go and find the ratios. AC over AB is 5.6 over 3.5, which gives you a ratio of about 1.6. Okay, now what about AB over BC? So let's find what is AB over BC. We take 3.5 divided by 2.2. We press calculator, we get 1.59 something something something. But to 2SF, that would be 1.6 as well. Okay, that is for question 1. So you realize that the two ratios are actually the same. Now let's look at question 2. Question 2 says use a calculator to find the value of 1 plus square root 5 divided by 2, correct to 2SF again. When you press calculator for this value, right, let's do it. 1 plus square root 5 divided by 2. Aha, you realize you get 1.618033989. Okay, so to 2SF, that is also 1.6. Okay, just now also was 2SF. Aha, so what do you notice about the values obtained in question 1 and question 2? They are the same. Okay, so let's write that down. They are the same. And this is what we call the golden ratio. Okay, which means just now, if we look at the diagram, right, the ratio of AC to AB, which is this whole part, AC to AB, is equal or about the same as AB to BC, these two ratios. Okay, and that gives us a very special golden ratio, which is the 1 plus root 5 over 2. Okay, and it's denoted by this symbol called phi, which is over here. It's an irrational number, just like pi, and truncated to 50 decimal places, right, is this long number over here given in your notes. Now, this golden ratio, as I mentioned before, can be found in a lot of places around us, like in nature, in architecture, etc. And supposedly, this is supposed to be the most pleasing to the eye. Okay, so they say that faces or structures with this ratio, right, are supposedly more beautiful or more pleasing to the eye, although I myself don't really believe in it because beauty is in the eye of the beholder and we shouldn't judge anything or anyone based on their looks. But mathematically, apparently, they say that this is the most pleasing to the eye. Okay, so we have structures like the Great Pyramid that follow this golden ratio as well. And this golden ratio, right, has some interesting properties. So let's use a calculator to find the values of phi square and phi plus 1. Okay, so if you press calculator, phi square actually gives you 2.618033 and so on. And if you press calculator for phi plus 1, how do I get phi in my calculator? I just press 1 plus root 5 divided by 2 to get that golden ratio, which is 1.618, etc. Then if I plus 1, I will also get 2.61803 and so on. So, aha, do you see that phi square and phi plus 1 both give you the same answer? Okay, once again, they are the same. And that's an interesting property because not many numbers have this property, right? For example, if you take 2 square, you get 4. Then 2 plus 1 is 3, totally different. But for this golden ratio, when you square it and when you add a 1, they both give you the same answer. Alright, the last part over here, use a calculator to find the value of 1 over 5. So you press calculator for 5, then you take 1 divided by answer. The value you get is actually 0.618033 and so on, okay? An irrational number. And what do you think this is equal to? Okay, this is very similar to this one, right? Okay, so how are they related? You just take the golden ratio, you minus 1, you get this 1 over 5, okay, which is also another interesting property that not many numbers have. Okay, so I will share the video with you after this lesson. And for now, let's look at exercise 9A from your textbook, page 45. These are the questions that you have to do on Foolscap. Okay, so you do question 7. Okay, then you do question 12, 13, and 19. Just 4 questions for you. For those who want to do more, question 20 is optional. Okay, I'll see you in my next video. Take care, stay safe, and bye bye.